this lesson, we will learn how to go from radical form to exponential form. Also, we will be simplifying expressions that have rational exponents. When a number is in rational exponent form, the denominator of the exponent is the root. The numerator of the exponent is the power on that base. A raised to the 1 over n power. The n is the nth root of a. With a to the m over n, m is the power on a, and again, n will be the root. Let's first review the rules of exponents before we go any further. With the product rule, if two numbers are multiplied together with same base, their exponents are added together. With the quotient rule, you're going to be subtracting the exponents. As for the power rule, you will see a product or a quotient raised to a power. In this case, the exponents get multiplied together. The zero exponent rule says any number but 0 raised to 0 power is 1. And as for the last rule, an exponent can be made positive by flipping the factor opposite of where it starts out. With numbers raised to rational exponents, start with the denominator on that rational exponent. For example, a 2 in the denominator means to take the square root. If it helps, we can rewrite these in radical form. So the first one is asking for the square root of 9. The second for the cube root of 27. The third is the cube root of 8. The fourth problem is asking for the opposite of the square root of 25. Notice how there are no parentheses. On the fifth, you are asked to find the square root of negative 9 and then cube it. But the result of the square root of a negative 9, is non-real. Notice the placement of these parentheses. As for the last one, take the root first and then cube. The fourth root of 16 is 2, and 2 cubed is 8. In the next few slides, we will simplify these expressions. Here, the numbers in exponential form are multiplied together with the same base. Therefore, to simplify, we'll be adding the exponents. For this problem, we have a product raised to a power. With the variable factor, multiply the exponents, and as for the constant factor, 4 raised to the 3/2 power, square root 4, and then cube for the result. Simplify requires that negative exponents be made positive. We flip to change the sign on the exponent. Here the x's and y's can be combined. My first step was to flip the y to make that negative 2/3 power positive. This is not the only way to start, but most students find taking care of negative exponents is the easiest. Since the x's are divided by one another, we apply the quotient rule, subtract the exponents. The y's are both in the denominator, multiplied together. Therefore, their exponents are added. This is a binomial multiplied by another binomial. We FOIL to start. After FOILing, we end up simplifying each term if necessary. With the first term, we apply the product rule by adding the exponents on the variables. The inner and outer products here will drop out. One way to start is to flip the entire factor in the denominator to change the sign on the outside exponent. Make sure to not change anything about the base, only change the sign on the outside exponent. Now we apply the product to a power rule by multiplying the exponents together. After freeing up all of the factors, everything is multiplied together. Therefore, the exponents get added for those factors that have the same base. Our very last step is to make sure all exponents are left positive. We flip that x to the negative first power. On this last one, we are asked to multiply these two radicals together. They can be multiplied together since the radicands are both x. Since the root is not the same for these two factors, we need to start by rewriting in exponential form first. After written in the exponential form, we see that the product rule can be applied. Adding the exponents together and then rewriting in exponential form gives us our final answer. Thank you for listening.